Hello everyone, this is Yixun. In Project 1, I use pep command to make the skin of roof. In Project 2, I try to find different methods to make various patterns of skin. Those methods include Voronoi, VB script, and a panel tool. I simplify the shape of my roof since it will be more easy to control and test. I also try to make solar analysis by gecko to find out the reasonable size of openings for the skin. It can be very useful data to modify my roof skin in the future. For the skin pattern 1, the first step is to make a rectangular surface. Use Pep 2D and Voronoi to make random cells within the square surface. The density of cells can be controlled by the count number for Pep2D command. Second step is to offset those cells and extrude the inner cells. Then use a solid box to manage those solid cells. In this way, the skin can be formed. Then I use solid intersection command to get the skin within the boundary of my roof. For the skin pattern 2, I use VB script to create the base shape of the honeycomb through polylines. Surface subdivision command is used to control the size, shape, and number of the hexagon. Similar with the Voronoi method, the skin pattern is formed first by solid difference between box and the extrude of hexagon within a rectangular surface. Then I use solid intersection command to get the skin pattern within the boundary of my roof. I think the panel tool is a very powerful and efficient way to make skins. The concept of this method is to make a skin pattern and a grid box on the surface separately, then copy the pattern into each box to form the skin of roof. The number and density of box can be controlled by the divide command, and the thickness of skin is changed by the height of surface box. By using panel tool, there is another method to make skin. A Move 3D command has a similar function with Move Box showed before, but compared with Move Box, Move 3D has more controllers and effects. The amplitude controls the thickness of the skin. A curve should be defined as a curve attractor which will control the distribution of points on the roof. If there is only one input objective pattern for the surface, it seems has no effects. For example, this one just has the ring shape pattern for the skin, so if I change the location of the curve, there is no change for the skin. Here is another example use the same method, but the skin pattern is made by grasshopper with several parameters, so there will be more controllers for the pattern of the skin. So if I change the number, the skin will be changed. If there are more than one objective patterns connected with Move 3D, the curve attractor will control the distribution of a point pattern. And for example, this one, there are 4 skin patterns connect with Move 3D. So if I move the curve, the skin of pattern will be changed automatically. To make solar analysis, first I need to test EcoLink to ensure my gecko can be used in Grasshopper. The roof surface will be set from a rhino into Grasshopper. I should change the surface into mesh. EcoMesh explored, mesh explored, and the mesh solar calculation commands will be used. And if it is correct, colorful graphic will be formed in the EcoText analysis software. Next step is aimed to make that colorful graphic into Grasshopper. EcoObject requires and the mesh color are applied to finish this analysis. So those are what I learned from assignment 2. Thank you for your time and have a good day.